Okay, so Saurav, let's proceed ahead with your snap for hydraulic machine, that is for Engineers India Limited, right?
Yes.
Okay, so what is the difference between turbine and compressor?
Sir, I know about turbine, but not about compressor. Turbine is basically used to convert the potential energy, or rather, I would say the kinetic energy and the pressure energy of water into mechanical energy.
So, can you classify the hydraulic turbines, Saurav?
Yes, sir. There are three types of turbines. One of them is the impulse turbine. The second one is the Francis turbine, which is again divided into old Francis turbine and modern Francis turbine. And the third one is the propeller turbine, in which we also have another category of Kaplan turbine, which is just a modification of propeller turbine.
Okay, so on the basis of the direction of flow, can you categorize all these turbines?
Yes, sir. So one of them, there are two categories in direction. Actually, we can classify into three categories as per the direction of the flow. The first one, impulse turbine, has a tangential flow, tangential velocity of the water. The second has the Francis turbine has a radial flow, and the old Francis one has a radial inlet and a radial exit, while the modern Francis has a radial inlet and an axial exit. And the third one, which is the propeller or the modification Kaplan turbine, have axial entry and axial exit. That is a totally axial motion.
Out of all these turbines, which one do you think is the most efficient?
Sir, I'm not sure of the efficiency order.
Okay, so if I give you Himalayan river,
Yes.
which turbine will you put in that?
Yes, sir. Since in Himalayan river we have a very high head available, so the impulse turbine are more suited for the same.
Why impulse turbine?
Because if we see the specific speed of the turbine, then the higher head and the lower discharge conditions correspond to a more efficient generation as per the Himalayan conditions and the impulse turbine.
Okay, why reaction turbine is called so?
Yes, sir. Reaction turbine basically makes use of the pressure energy of the incoming water as well. So it converts the pressure energy into kinetic energy of the it converts the pressure energy into the mechanical energy of the turbine. So that's why we call it as a reaction turbine.
Okay, so you know what is the degree of reaction?
Yes, sir.
What is that?
Sir, it is the proportion of the power generated by the change in pressure out of the total power being generated by the turbine.
Okay, what is the degree of reaction for Francis turbine?
For Francis turbine, sir, it lies between 0 to 100, but it is not 0%. And the exact value, I'm not sure about it. But lies above. It is a non-zero value for Francis turbine.
You know something about whirl velocity?
Yes.
What is that?
Yes, sir. It is the tangential component of the final velocity, of the absolute velocity of the water.
And what kind of angles do we have, blade angles do we have in turbine?
The beta blade angles. Yes, sir. So we have them in various ranges. So for backward turbines, which we have about less than beta. For forward flow turbines, we have an angle of beta angle of greater than 90 degree. And these are basically the classifications of the forward flow and the backward flow.
Okay, can you tell me, Saurabh, what is the draft tube?
Yes, sir. So draft tube is an instrument which we use so that the kinetic energy of the outgoing water is not wasted much and is converted into our useful energy as much as possible, and it allows us to place the turbine above the tail race level so that we can take care of the maintenance without reducing the power output of the turbine.
What is the main advantage of this draft tube?
Yes, so there are two primary advantages. First one is from maintenance point of view, that we can we can position the turbine above the tail race level and for easy maintenance without compromising on power output. The second advantage is that we can make use of maximum kinetic energy of the water, and the kinetic energy of the outgoing water is reduced to a bare minimum.
Okay, so if I give you a velocity diagram, seeing that velocity diagram, can you tell whether it is Pelton, it is a reaction turbine, or it is impulse turbine?
Yes, sir.
How?
Yes, sir. So in the case of an impulse turbine, the velocities, then we have an angle of deflection in it as well, and it has a peculiar different diagram than we have in the Francis turbines and the Kaplan turbine. One distinguishing feature in Francis turbine is that for maximum efficiency, we have a zero whirl velocity at the outlet, which is not the case for impulse turbines.
Okay, so can you tell me something about net positive suction head? What is the meaning of that?
Yes, sir. NPSH or net positive suction head is basically a margin against cavitation, and it implies how much is the pressure being applied on the liquid at the suction side of the house.
Okay, let me give you the feedback now, Saurav. So I think you have studied the fluid machineries, the part you have studied that well, but there are certain things which you are still to prepare, right? The kind of questions which I asked you.
Yes.
Go for this hydraulic pump, hydraulic this turbines, and velocity diagram analysis, kind of efficiencies we have. Go
Yes.
for those, right? And
Yes.
efficiencies part. How can you compare efficiencies of these turbines? Reaction turbine are supposed to be more efficient than impulse turbines.
Yes.
Find out why it's called more efficient. What is the reason of more efficiency? Go for that, right?
Right.
And the rest, I think you have answered more or less the questions. On the similar lines, the question will be asked. Go for more fluid machinery if you want, right?
Yes.